Hello everybody, we are here on section 3.3 and we are determining today if things are functions or not. A function is a relationship where no x repeats. Let's go in and find some examples here of what is and is not a function. So like I said, we're looking at where no x repeats, so we want to zoom in on those x's. Here we have a 2, a 3, a 6, and a 10. None of those numbers repeat, so that is a function. For our non-example, we have 2, 2, and 3. As you'll notice, my 2's repeat. That's why it's not a function. Let's look at some more examples to determine if things are functions. 5, 3, 2, 0, -1. Here, none of my x's repeat, so that is a function. -2, 0, 2, 3, 2. Here, my 2's repeat, so this is not a function. -4, -3, -2, 1, and -3. Here, my -3's repeat, so that is not a function. 1, 2, 3, 4, 5. None of my x's repeat, so this is a function. When we're looking at tables, it's the exact same idea of looking at just our x's and seeing if they repeat. 3, -1, 0, 2, and 3. Here, my 3's repeat, so this one is not a function. -4, 2, 1, 2, 5. Here, none of my x's repeat, so this one is a function. -5, -3, 0, 1, and 2. None of my x's repeat, so this one is a function. 1, 4, -7, 4, -1. Once again, my 4's repeat, so this is not a function. -8, -4, 0, 4, and 8. Notice none of my x's repeat, so this is a function. 1, 2, 3, 4, 5. Once again, none of my x's repeat, so this is a function. Now when we're looking at mapping's a little bit different. As you remember from before, mapping, we're drawing arrows to connect where my points are. So for example here, this one would have a point of -3, 0, -1, 4, 2, 7, and finally 4, 4. Those all represent the points that we have here. So you notice here, none of my x's repeat because there is only one line going from each of my x's. So this one is a function. You can highlight here that my -1 has 2 lines exiting. Because this has 2 lines exiting my x value, that means that x repeats, so that one is not a function. Here on 13, all of my x's do not have, or only have 1 line, so this one is a function. Let's talk about the vertical line test to figure out how graphs are functions or not. So the vertical line test is when we are going to take a vertical line and drag it across the graph left to right. If the line hits a point more than once, it is not a function. So this is a test to figure out if a graph is a function. Your line should only hit the graph once. All right, so let's show some examples. So this would be an example of a function. I'm going to draw my little graphs here. That is a function. That is not a function. Let me show you why. I'm going to go ahead and draw. Perfect. So as I move this across, you'll see that it only ever touches that highlighted line once. If I take it over to my non-function, you'll notice it is now touching my line twice. Once here and once here. Can't have that. Let's go ahead and show some more examples. You can do this with your pencil or with a ruler, anything like that that you can drag across. So as I drag across here, right here, I'm hitting my line twice. That is not a function. Let's try this next one. Here we're good. Good. Only once. Still only once. And only once. So this is a function. Let's try it again. So once again, I'm dragging my line across. And as I drag my line across the graph, it only hits it once. So that is a function. From here, as I drag it across, you'll notice it's hitting it multiple times. Here and here. That means this one is not a function. Let's try a couple more. This is the example that I gave up above. Once again, hitting it twice. That is not okay. This one, once. This one is a function. This is a tricky one, because as I drag it along, it only hits the line. This one is not a function. That is a vertical line, no function. 21 here. I drag it across, still hitting only the graph once, which means this one is a function. All right, I'm going to zoom out so you can see all the answers once more. All right, guys, that is the conclusion of these notes. Go ahead and do the assignment listed above if you've got any questions.